So myself, P.R. Solom, Assistant Professor of AML Department from Hindustan College of Engineering and Technology. So now I am going to present a video about what is linear regression in machine learning. So first we will see what is linear regression. Linear regression is a supervised learning algorithm used to predict a continuous output based on one or more input features. So it finds the best fitting straight line in 2D or hyperplane in higher dimensions through the data. Okay. If we see the types of linear regression, there are basically two types, that is simple linear regression and multiple linear regression. Whereas simple linear regression, there is one input feature, that is one independent variable, and in multiple linear regression, two or more input features are there. And if you see the goal of linear regression, to model the relationship between input variables x and output variable y using a linear equation. The equation is y equal to w0 plus w1x, where y is the predicted output and x is the input feature, w1 is the slope and w0 is the y-intercept. And for multiple inputs, we use y equal to w0 plus w1x1 plus w2x2 up to wn xn. This is the formula for multiple linear regression. So how it works? So linear regression learns the weights by minimizing the mean squared error between predicted and actual outputs. The last function is MSE, that is mean squared error equal to 1 by n, summation of I equal to 1 to n, yi minus yi bar the whole square, where yi is the actual output and yi bar is the predicted output here. And next we will see one example problem here, that is predict a student's exam score based on hours studied using linear regression. So this is the given data, that is the x-axis is hours studied and y-axis is the exam score. So it is numbered from 1 to 5 in our studies, and the exam score is numbered as 50, 60, 65, 70 and 80. So we want to build a model that predicts the exam score from the number of hours studied. So in step 1, we have to visualize the data. That is, when plotted, the data shows a trend, that is more study hours gives higher score. Looks like a straight line, can fit through the points. So this is where linear regression works well. And step 2, we have to assume the linear model. We use the equation of a straight line, that is y equal to w1x plus w0, where already we know x is hours studied here and y is the predicted score, and w1 is what? Slope, and w0 is intercept. And next step 3, calculate the best fitting line. So we compute the values of w1 and w0 that minimize the error using the least square method. So let's calculate for finding averages. First we have to use what? We have to find the average for x bar, that is x bar equal to 1 to 5 divided by 5, that is equal to we get 3, that is the average of x. And also we have to find the average of y, that is what we are getting here, 65. And next one, compute the slope w1 by using this formula w1 equal to summation of xi minus x bar yi minus y bar divided by summation of xi minus x bar the whole square. So by using this formula, we can compute the slope w1, that is finally we are getting here 7. And next one, we have to compute intercept w0 by using the formula w0 equal to yi bar minus w1 x bar. So in here we are getting the output for w0 is 44. And next step 4, that is final model. We are getting what? Y equal to 7x plus 44 by using the straight line formula. So this is your regression line formula, regression line now. So from this we can make predictions. For example, let us predict score for a student who studied 6 hours. So we get what? Y equal to 7 into x plus 44, we are getting what? 86. So for 6 hours of study, the predicted score is what? 86 here. And next one, we can evaluate the model, that is optional case, use metrics like MSE, that is mean square error, R power 2 score, etc. to measure how well your model fits the data. So final summary we are seeing here, that is step 1, we are computing means of x and y, and next step 2, we are compute slope w1, and step 3, we are compute intercept w0, and step 4, we are finding the final model, and step 5, we are predicting for the x value such as 6. So thank you.